It's it's difficult to get the whole green screen thing right sometimes. Am I? Oh, that's weird. Look at that weird creep. What is up with you? Uh, uh. No one tell the fine folks at Industrial Light and Magic how bad I am at green screens. They'll be sending me consulting bills. All right, let's see if we can fix this thing for real. I don't know what's going on here. It's all just a fun game of moving the tripod feet ever so slightly until we have full green screenery. How wonderful. How wonderful. All right, can everyone hear me out there? Are we like fully in effect? Or am I just talking to myself? Sometimes it's hard to tell because I know there's like lag. Right? It's weird lag. Yes, hi from Orlando. All right. Let's get out one last tweet to let people know that we're starting up here. Let's see here. It's a bit quiet for me and had to turn everything right up. Huh, weird. Maybe, let's see. Did I mess with any settings? I don't think I never mess with any settings over here. I like to do the opposite of messing with settings. Is it any better now? I just put the microphone closer to my... It's like apparently the very pinnacle of tuning audio is just put the microphone closer to your mouth. Could also try speaking like don't have a mouthful of dry turkey. Apparently a pretty decent idea. From Verona. Which Verona? There are many Veronas in the world. You're going to have to tell me. New York today is doing all right, as far as I know. I haven't heard anything bad. It was trash day, so I've been up since 5:30. As the trash trucks come by, and boy, do those sanitation workers just make a racket. It is crashing and banging and booming. They are not shy. I think sanitation workers are mad because they have to get up very early and like pick up trash, and so the noises that they make when they pick up your trash are just like be loud as possible. The real Verona, Italy. Wow, I've never been there. We had a trip to Italy planned for this summer, but of course that's not a thing anymore. This international travel right now seems a bad idea, but hopefully next summer we'll be able to make it. We'll be able to redo the trip we had planned for this summer. Last summer we just went to like France. It's only 11:30 a.m. where we are in Phoenix. 105. Woo, 105. That is a face melter. That is terrible. Let's see here. Let's see. What is it? Let's back out of the slide real quick. Let's see here. Where is an audience safe browser? Amphitheater is beautiful. I would love to see an amphitheater. A real Italian amphitheater. Get one of those like funny Italian theater masks. I love those things. Let's see. Wonderground Brooklyn. Well, that's weird. Comma NY. Just anywhere New York, right? Just comma NY. Any old wind that blows. Let me make sure that I have Zoom It killed on my laptop so that I don't accidentally laptop zoom instead of VM zoom. There we go. Comma NY. Any old place in NY. Bonsai Buddy Rods, you know it. All right, so let's see. It is 91 Ah, shut up, privacy policy. Yeah, 91. May feel like 92. I don't know what that low of 68 is. Tonight there's a low of 68. I don't know about that. Ooh, tomorrow is my kind of weather. Tomorrow is well, sort of my kind of weather. I prefer cold and rainy, but who knows? I'll be smiled upon and it won't be 89. But I like thunderstorms. I like rain. Uh-oh, looks like the coronavirus on Wednesday. That's no good. Uh, wow, it's a low number though for New York anyway. Some other places it's normal, but holy cow, let's see. Is it buffering a lot or is my girlfriend hogging all the internet? Well, don't call her a hog. It's a bad way to have a good night. Trust me on that one. Let's see, what is the 10-day here? Dang. Oh wait, did I go on the 10-day? No, that's the hourly. 10-day. Yeah, 33. I know your tricks, Europe. I know your Celsius tricks. Let's see. Ah, yeah, it's a lot of hot. A lot of hot in there. No buffering there. All right, Lee, you're going to have to move to Orlando to fix your buffering issue. It's settled. Welcome to Orlando. You are now a citizen of Orlando. All right, let me just do a quick speed test. When I do a speed test, I am most likely going to end up buffering, but I just want to get a general idea if my internet is like totally zonked right now or if it's like an okay shape. So I'm just going to do like a quick one just to like make sure. Okay, yeah. So my throughput right now is kicking butt. So I'm not too worried there. Not too worried there. Yeah, I get gigabit too. It's nice, but you know, it's always a theoretical gigabit, right? It's always a theoretical gigabit. It's like, yeah, it's like I would love to, you know, actually I don't even have one for this. I got nothing on this. Sorry about that. First in COVID cases, ninth in obesity. Well, you know, that's a bad Venn diagram of COVID and obesity. I hear they don't get along well. All right, let's. There are enough people here, right? I think there are enough people to get started. Maybe. I'm happy. At least I'm happy with the number of people here to get started. So let's not have too much further ado because Adu is a busy person, and every time we further ado gets angry. I like Adu, and I don't want to inconvenience our poor Adu. So what we're going to talk about today is my favorite way to we're talking about a few different ways that you can write page inquiries. We're going to talk about my favorite way to write it. And then we're going to get a little bit more advanced, and we're going to get into, because whenever I see people using page inquiries, it's never just, you know, a very simple, oh, we just need to page through this result set. It's always like, we have strange needs. It's like, it always ends up as being dynamic SQL. And it always ends up as being, you know, we need to be able to have a different where clause, order by different columns, have different page sizes. Lots of different things end up coming into the picture. And I want to cover sort of the most common ones. There are many additional edge cases. Sometimes people need to order by multiple columns. Sometimes people need to have conditional joins. But that's, you know, fairly trivial to add on to the sort of outline that I'm going to give you. I'm not saying it's like perfectly trivial, but it is fairly trivial. And, you know, I think, you know, as long as you don't give users too much power and let them start dictating like which columns they want to show from SQL Server, if you want to give them that ability to pull in or cut out columns in the app, cool. But doing it at the database side, it's a messy nightmare because then you just open yourself up to all sorts of weird possibilities. Like if they mistype a column name, there goes the query, right? There's the more you can cut down on user inputs, the better off you are, right? Definitely. Definitely. So, I'm sure most of you know that I'm doing an online class this Friday. That's going to be the 26th. It's going to be streaming just like this, except it's going to be taking place on my site rather than on. Slide jumped ahead on me a little bit there. It's going to be taking place on like via my website. They got a whole password protected thing going on there. And if you want to join, cool. As a thank you for showing up today and loitering and not and spending your company money with me. If you use the coupon code PagerDuty right now, you'll get $75 off admission. That'll knock it down from $200 to $125. And just like the previous slide says, if you sign up to take that class on Friday, you get access to all the video training on my site, not just the stuff that I recorded for the class. You get access to the whole kit and caboodle, all of it. So it's like $1,000 worth of SQL Server training for like $125, which is a pretty good deal. So I will put the coupon code, not the Decepticon code. That would not work out well. I'll put this up again at the end of the session, just for anyone who might miss it. But it's up there just in case you want to use it. You want to come spend your Friday with me learning all sorts of goodies and bits and doodads about SQL Server performance. So anyway, let's get on with this show a little bit. Now, this is me rehearsing demos. And the thing about me rehearsing demos is that, it's fun. Because I always forget what I want to say. No, I'm kidding. It's fun because, I like to get some audience participation, some audience feedback about what I'm doing. And, maybe it helps me write better queries, explain things a little bit better, use like that fake presenter psychic ability to anticipate questions and start answering them while I'm talking rather than like waiting for someone to say, but what about the blah, blah, blah? Because it's always the but what about that trips people up. It's like always that thing. I'd have to think about that. I'm going to think about that for a long time. It's just like gazing off into the distance like, what could it be? I don't know. So that's always a good thing. So what we're going to talk about first is just sort of simply a few different ways to write paging queries. And of course, where paging query performance can start to get thrown off because, and it's fairly trivial to write a paging query. There are a million examples of writing a paging query out there, but performance is always where things start to get tripped up. Dave DNZ says, do any of them not suck? Well, yes, but they all involve math, which sucks, so they all kind of suck. There's no great one. And as far as I know, there's no database platform that really gives you a great way to write paging queries. You kind of have the same choices in all of them. I understand that like in Oracle and Postgres, you have row IDs, which can make this a little bit easier. But if you in SQL Server, if you've got a primary key, you kind of have the equivalent, just without that I don't know, whatever Oracle and Postgres give you goodness. It's all it's all a coin toss. I think the problem is all databases suck, so all paging queries suck. Let's see. Dave says caching and app level paging is the only thing we found that works. Well, maybe I can give you something else today then. Maybe we can talk about something else. I don't, without knowing exactly what problems you've hit and faced in your time trying to write paging queries. Well, maybe I can give you something interesting. So we got query plans turned on, and as far as I know, these are like the three most common / simplest / most sensible ways to write a simple paging query. So all of them kind of need two things to start off with. One of them is a page number, so we know what page to start on, right? So if we need to skip to page 5 or 10 or 20, we can do that by telling SQL Server which page number we want to end up on. And we also need a page size. So we need to know how many rows we want on each page, so that if we, like if we go to page 20, we're not skipping by like 10 rows. Where we need to be skipping by 100 rows, right? Let's see. Dave says multi-tenanted databases clustered on GUIDs, paging through 50K rows 50 at a time. Maybe. We'll see. We'll see what happens. I think I mean, I don't know that I'm gonna do that exact scenario here. You've got very specific problems, Dave, but we'll see what we can do. So what we're going to use is what I'm told by very smart people is called zero-based math. So what we need to do is if we're going to end up on page 1, right? If we're going to tell SQL Server we need to be on page 1, that's actually page 0. So we need to do a little bit of math to make sure that we are on the right page and that we end rows at the right place. And we can do that pretty simply with this query. What we're going to do is, now this is like the simplest possible form, just to give everyone an introduction. We will get into tougher stuff when we get to this one over here with a B in it, right? 8B, that's where things get tough. 8A is easy. 8B is where things get more complicated. 8B is where things start to get a little bit hairier. Not like the jet, like the back. So what we're going to do is we're going to generate a row number. Right, we're gonna, oh, that should be over there. I don't know what you're doing over there. That looks very silly. There we go. That looks better. That's all lined up now. Now my OCD is at ease. So we're gonna select just the ID column and we're gonna generate a row number over the ID column. Because it's the primary key clustered index of post, this is gonna be very, very simple and very, very easy. But when we run this query, right, we will get back we can validate and verify that we got back. Let's zoom on into the bottom here. We got back our 100 rows. Good for us. Okay, so our math works. Yes, Coyote make the yay math. Yay math. Secret to the universe and all that stuff. And if you look at the execution plan, this was very, very fast, right? We see some goose eggs across here. Noel and Ryan couldn't give us these kind of goose eggs, like all zeros. This thing finished just about as fast as you could ask a query to finish. This is one simple way to write a paging query. Another way that, so Dave D from NZ, you might know a guy named Paul. And a long time ago, actually one of the very first articles I read after getting into SQL Server was this article about server-side paging, where Mr. Paul White talked about one method that he had come up with using common table expressions, each of which had a different top query inside of it. So what we would do is we would use the first common table expression to select the page number that we want to be on, or the number of rows we want, and then we would filter out that number of rows in another common table expression where we filter on the row number generated up here, right? So we would get sort of like a full result set here. We'll generate the row number, and then we'll filter on that row number in the second one, and then when we come out of that, then we'll join back to whatever tables we need in order to get whatever columns we want to show. For right now, all we need to do is get that ID column, because that's going to tell us which rows we need to join back to in the base table. And if we run this will be equally fast. If I remember to highlight the whole thing, one of the worst parts about this demo is remembering to highlight all the declares so that I make sure that we end up in the right place. Maybe, you know what? This is actually probably a pretty good idea. I should have at least one example of these queries where rather than having these declared variables in there, I actually have the literal values in here so that people can see a little bit. Maybe it's conceptually a little bit more easy to figure out exactly how the page number and page size variables work in here. But I'll let y'all tell me if that's a yes or a no in chat. For me, it's pretty easy to see. Okay, page number is 1, page size is 100, page number, page size. But if if you agree with me, disagree, let me know, because that's the only way I get better is if you let me know. I don't get better if you don't. Right? It's like, no one knows how annoying those toothpaste specks on the mirror are until someone says, just really try to keep those toothpaste specks off the mirror. But anyway, this query finishes relatively fast. And if you're on, now I was actually thinking about over the weekend that when I say things like, if you're on newer versions of SQL Server, I could right now very, very easily replace that with if you're on a supported version of SQL Server. Because, a lot of the time when people are telling me that, something didn't work on on like a demo that I showed them didn't work. I'm like, oh okay, well, I was using SQL Server 2000, 17, 19, something like that. What version of SQL Server are you on? They'll say, oh, well, I got the old 2008 R2 developer box. I'm like, well, that's not going to work. And I realize that not many people need Microsoft support on the developer box, but by God, that poor developer box, it's a decade old. Anyway, so one thing that was introduced in a newer version of SQL Server, and by newer version I mean SQL Server 2012, which is the cutoff for supported versions right now. One thing that got introduced there was the ability to use offset and fetch. Offset and fetch are not implemented any differently, really, from the top operator. It's just a different way of expressing the same syntax. And I think a lot of the offset and fetch implementation stuff for SQL Server was really just to make, porting code from, say, Postgres or Oracle or another database platform that had offset and fetch and not top. Top is very specific to Microsoft. Top is Microsoft only. So having offset and fetch in SQL Server makes it a lot easier for people to come from other databases, use offset and fetch, and not have to worry about replacing every offset and fetch with a top. Even though top can take an expression, it's, whatever. But you can write a query that uses offset and fetch, and it will also finish very quickly. And it'll be a pretty simple query plan, and we will get the right number of rows back, and all that stuff sort of checks out. So all three of these examples just kind of do the same thing in different ways. It just depends on what you're more comfortable with, which one you like. If you really like offset and fetch, you can use this one. If you really like Paul White, you can use the second one. And if you don't like either of those, if you for some reason don't like Paul or for some reason don't like offset and fetch, get out. No, I'm kidding. I'm kidding. You can stay, but you have to like Paul if you're going to stay. But if you want to use the first one, you can also use this first one. It doesn't make a difference to me. You can do whatever you want. I think this one is probably the simplest to turn into a dynamic query. So this is the one that we're going to use in the more complicated examples, but not really the point. So one thing about paging is that whenever you need to go deep into a result set. Now this query isn't actually going to return any rows. And one thing I want to point out is that because I am declaring variables up here, I have a recompile hint on all of these. And I have the recompile hint there so that we don't get hit with any weirdness in here. I've never really looked specifically at how this stuff might throw things off but maybe that's a good blog post. I'm going to write this down. I'm going to say, write a blog post about local variables and paging. That's a good idea for a blog post. Because now I'm interested. Now that I said it out loud, I'm interested. So we'll do that. So I'll write that up, and I can thank all of you for being here and inspiring me, not expiring me. I am not milk. But one thing that sucks is going deep into a result set. So this query here, where I went 1 million pages in. 1 million pages in. To just get 100 rows, returned absolutely nothing. If we look at the execution plan, we just spent a whole heck of a lot of time scanning a clustered index and trying to find some rows, but we found no rows. We did not. We found nothing, and that still took us a long time to find nothing, even with a recompile hint there that is of dubious utility. But I like it there. It makes me feel better. Makes me feel better about things, which is all that matters at the end of the day. So we have these three queries, and this would happen no matter how we did it. I don't see too much wisdom in looking at if this would happen for all of it, because it really would. The deeper you have to go in, the worse things get. Lee says, quick question, using such a method, would you always recommend using recompile? I missed what you just said. So if the query is a store procedure, or this query is a store procedure where you're accepting page number and page size as parameters, then no. I just have it in here because I'm running ad hoc SQL. If you have, if you have a store procedure, or if you're using Entity Framework or something else that runs SP execute SQL and accepts parameters that way, I probably wouldn't have the recompile hint in there unless you hit really, really weird issues with parameter sniffing. Then it might make more sense, but there are also different ways of dealing with that when you have dynamic SQL that, I wouldn't necessarily jump to the recompile hint unless I really had to. But that's something I have a module on dynamic SQL, but I'm not going to be able to get to it today because it's a big one. It's a big one. All right. So that was all fairly trivial. And this was all fairly trivial. Let me go back a little bit. This was all fairly trivial because the ID column in this posts table is the primary key and it is a clustered index. So we have this in index order. We have all the ordering that we need to do for this thing supported by the index. Having this column in index order means sorting it is free. If I need to generate a row number over this column, it's totally free. I don't have any other indexes on the post table right now. I'm stuck with just this one. I'm stuck with. I say it like it's a bad thing. It's a fine thing to have on there. You have a column called ID. Again, having an index on it is probably a pretty smart thing. But let's run this query and let's do something a little bit different. Let's use this last activity date column instead. So rather than ordering primarily by ID, we're going to order primarily by last activity date and then by ID as the tiebreaker. Last activity date isn't unique, so even though we're ordering by it, the order by is non-deterministic. We could have ties in there. So if we need a unique key that is the tiebreaker for that. And thankfully, we have this ID column. That's our primary key. That's our clustered index. So we can use that uniqueness as a tiebreaker. But what I'm going to show you is that for all three of those queries that used to be very, very fast, if I run them now, even with the recompile hints, they're going to slow down a bit. And they're going to slow down a bit because we need to sort data because we do not have data in index order anymore in order to get the results we need. All three of these queries are going to return the same 100 rows, right? They return everything. We can see the rows down the bottom changing to 100. But rather than finishing very, very quickly, the three of them took just about 9 seconds total to execute. They're all going to have just about the same runtime. There's a little bit of variation, but not so much that I'm like, wow, you're the big winner. You performed so much better than all the other ones. Good for you. It's not like that. But if we go look at the execution plans, I got tangled up there and I hit the wrong button. If we go look at the execution plans, that first query that was finishing in all zeros, that's taking about 3.5 seconds. This is about 3.5 seconds, and this one down here is about 2.1 seconds. So the offset fetch turned out a little bit better here, but again, not so much that I'm like, oh, I'm just going to use you forever. Wow, that second really saves the day. But what's different is that for all of these queries, we now have to sort data. All right, we have to go and we have to order data by that last activity date column. If we zoom in here, we're going to see our order by is on last activity date and then post ID. Since we don't have an index keyed on last activity date anywhere, we do not have that last activity date stored anywhere in a helpful order. Last activity date is at the mercy of the order of the clustered index right now. So the clustered index is going to count from 1 to however many posts are in the table. But the last activity date is going to be scattered all throughout the table. Sometimes you might have columns that are implicitly ordered together. Meaning if you had, like in the post table, there's an ID column and there's a creation date column. Typically, if the ID column is ascending and you put things into the table in order, right, by order, the order that they're created, ID and creation date would share ordering because creation date would increment with ID as it increments as you put data into the table. So sometimes when you have columns that share ordering like that, you can skip needing to, like specifically for this table, like you can skip needing to order by like a secondary column, like a creation date column, because you can technically order by that ID column, which is indexed and supported. And you don't need to worry about the creation date column so much. SQL Server is not smart enough to pick up on that on its own. The optimizer doesn't have that trick up its sleeve. But not that I think it should. I can't see Microsoft investing a lot of time in that particular trick, but who knows? Who knows, right? Eventually, maybe paging queries will rule the world someday, and the customer experience improvement program will take note of just how many people are are using paging queries and they'll say, boy, oh boy, I sure do wish that I wish I had that knowledge. But the last activity date column, it's scattered all throughout the table because people will write a question, write an answer. They might come back a year later and update it with new information. They might come back 10 years later and update it. So even a post made in like 2008 could technically have a last activity date of 2018 or something, right? Like the post never, unless a moderator locks a specific post for a specific reason, you can go back and edit them willy-nilly. The last activity date really is scattered everywhere. So we don't have that index, we don't have that column in any specifically helpful indexed order. All right, so all of these queries kind of suck now. But if we go back and we create an index on last activity date, right? We say, give me that sweet order index order. Now remember, because ID is the primary key in clustered index, it's going to be implicitly present as a key column in this index. It'd be just like if I had the index defined like this. But we don't need to explicitly do that because SQL Server needs that clustered index key column and non-clustered indexes for all sorts of fantastic reasons, like checking for corruption and doing lookups and things like that. Index intersection and union and all the magnificent things that happen in query plans. But when we run these queries now that we have an index on that last activity date column, they're all back to being fast. Right? This is all zeros, this is all zeros, this is all zeros. Even going down to the offset fetch query plan, we have zeros across the board here. So the bottom line with paging queries is that as long as you use one of these forms or another form that gives you equivalent performance, the way that you write the query is secondary to the indexes you have to support the query. And what I mean by that is whenever you need to figure out which row and page you're on and you need to order your data, you need to be able, if you have an index to support that ordering, you will be in good shape. Without an index that supports that ordering, you can be in tough shape. Where things get really, really difficult is when you have to manage where clauses and joins and other things, and indexing for those as well as any potential sort orders. A lot of applications that I see just give people far too much free reign to be able to filter on whatever they want, order by whatever they want. And, a lot of them have very, very difficult schema where, they have that, the tables just keep getting wider rather than and there being any sort of normalization because they're like, oh man, I don't want to add another join here. I'm just going to add some columns to this table so I can get everything in one place. And then people just hit the table in totally different ways. Like their where clause just starts getting weirder and weirder. Like their order by just has way too many available columns. And they're like, oh boy, we're screwed. So server-side paging is generally a pretty reliably easy thing to write and to implement well, but it does require the right indexes. Now, as soon as users start wanting custom where clauses, optional joins, getting counts of total matching records, that really does complicate indexing and querying the base data. Now, I have links here to the articles that I talked about that Paul White wrote, and hopefully those come out. Yes, they did. Wonderful. They come out as two separate links. If you want to go in the Wayback Machine, back to 2009 or 10 or something, and check those out, they're still very valid today. There's still a lot of good information in them today. What I will say, stop and say right now, is that sometimes a fully normalized schema is not a good idea for these kind of paging reports. Sometimes a better idea is a wide table where you have all the data in one place and you can sort of index it more freely. And I say more freely because if you have a bunch of OLTP tables that you're trying to do this paging stuff over, it becomes really, really difficult to index for your OLTP workload alongside this reporting workload. Sometimes you can get away with it, other times you can't. A lot of it will depend on hardware, isolation level, sort of like the locking and blocking profile of user queries. If users can do crazy stuff like open something to edit it and it'll lock it, all this other stuff, just kind of like nightmare scenario stuff. But Sometimes the denormalization to like one big table is a good idea, but that comes with a pretty high overhead of having to do stuff like write triggers to move data into the table, synchronize things, again, please forgive me for saying this word. If you have to use a merge statement to put data into that table, figure out whether you need to insert or update or delete it or whatever. And then, sometimes you hit a point where SQL Server is just no longer the right vehicle for these kind of reports. Things like, it's cut off here, but things like Elasticsearch are made for queries like that, and or are pretty well designed for search queries like that. And it just might be an easier solution to get Elasticsearch for free, right? I say for free because the downloading and implementing the technology is free, but the human cost, right? The hardware cost, there's still some costs in there of like figuring out how to get data in there and then query it. Sometimes this moving stuff out of SQL Server is a better choice because let's face it, databases are stodgy and have rules. Things like Elasticsearch just don't have that. They don't even have passwords. So if you put it out on the internet, people are free to just come and go as they please. So good stuff there. He says, 8,000 line procedure handles our paging with a lot of dynamic SQL and logic. It does not run well, but I'm scared of it, to be honest. Well, Lee, boy, do I have good news for you. Maybe. All right. And let's get to some good news because, everyone likes good news. Right? Except economists. I think economists like bad news because it keeps them employed. If the economy were just always good, we would need economists, right? We'd just be like, what's the economy like today, Mr. Great. You just check in. What is it? Fantastic. It's like being the weatherman in Southern California, or weather person. I'm sorry, weather person in Southern California. Just what's it like? Pfft, great. Don't sweat it. Let's see. Dave says, Lee, you don't work for the same company as me, do you? Oh, boy, I'd love to have a love connection in here like that. All right. So this is the store procedure that I have. It's going to do the paging stuff, good paging stuff, and I have things separated out a little bit to help I hope there be some like sort of like logical understanding of the parameters that are getting passed in. So the ones here that are capitalized are going to be user inputs. So owner, user ID, creation date, last activity date, post type ID, score, title, body. These are all things that users can pass in and can search on. The things down here that are in lowercase are things that the application passes in, or that aren't just sort of like open fields. So like we can have a page number of 1, we can have a page size of 100, we can have an order by column, we can have an order direction. So we can do some stuff in here that normal end users will want to do, right, to page through a result set, but some of them are user supplied, other ones are just kind of like user preferences. So like, we might want to, we might come up with a whole bunch of different search things, but we might always want to use the same search preferences for things. So, I tried to separate things a little bit there. So I'm going to, like a true professional who has read all of Erland Sommerskog's works, I start all my store procedures with set no count and exact abort on, even though we're not opening a transaction here, and we're not doing anything that I think would even have anything to do with it. I don't want to ever incur the wrath of Erland, whether online, in person, even just him mentally, wrathing upon you. I hear is just deleterious to one's psyche. So we're going to skip over all that. And I'm going to declare some stuff up here that will help us later. So we have an varchar max variable that will hold our dynamic SQL string, one called filter, which will hold our dynamic where clause, and something that will help us pretty print some nice stuff, or help us pretty print our dynamic SQL so that's readable to anyone who might need to debug it later or something. I'm not gonna fully get into all if you need to debug or not execute stuff in here. I'm just going to get into the performance stuff. There's a lot of things that you can do with dynamic SQL that are very, very good ideas to do, that help you, identify the store procedure, pretty print stuff for anyone who might need to go back and look at look at what the query that actually executed was, maybe log it to a table, all sorts of stuff like that. But I got to focus on the performance here. If you want like a master class in dynamic SQL, that's cool, but I really care about the performance of paging queries in this bit. So I have like minimal exampled error handling here. So like if the order by column is not one of these columns, we're going to say you're not allowed to order by that. And this is something that I would do in my anything that I was writing in production too, because notice we have some sort of crap in here, right? We have this title column that's in varchar 250, but more importantly, we have this body. We have searches against this body column, which is an varchar max. I don't want anyone trying to order by an varchar max. It has to, the insanity must stop somewhere. At some point, users are wrong, and they must be punished. But what we're going to do is use some dynamic SQL, and we're going to use that dynamic SQL to build up the correct string that we want to execute so that we can search through things, and we can also have things perform well. Now, what I'm going to do first is have the dynamic SQL bit that's going to get us our ordering and get us our searching, right? Implement our where clause. So this part up here is going to start with the query that I showed you back at the beginning, right? It's going to be this query here where we use a common table expression. We select the ID column and we generate a row number, and we do that from the post table. But notice this common table expression ends right here. Right, this is the end of it. We don't do anything else here. There's no where clause. There's no searching for things. We're all just, we're just sort of hanging out doing whatever. Here, we're going to have to do a couple things. We're going to have to supply an order by column, right? So whatever order by column we pass in over here is going to have to show up in here. We're also going to have to supply an order direction. Right, we're going to have to tell SQL Server, do we want that A for ascending or D for descending? I'd like to keep this to the one-letter variety just because I don't want anyone getting carried away and making anything like this more prone to SQL injection. But, it's already pretty hard to do this with the way I have things set up, so I'm not going to get into the whole security aspect of dynamic SQL. Granted, it is fraught with oddities and it can be perilous, but one thing I do want to do is if someone doesn't say ascending or descending, I really want to mess with them. So if they don't supply a valid sort order, if they put in like Z or a question mark or like a fart noise, they're getting ordered by new ID descending. Good luck getting query results from that, jerk. You're not funny. The next thing we're going to do is we're going to end our row. So this part all this part here is just ordering by, or giving us our row number. Order by P dot quote name blah 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 blah. And then we have where 1 equals 1. And then we're going to use a pretty standard way of handling like the kitchen sink type queries in order to build up our where clause based on whatever users are after, right? So we're going to have where owner user ID equals owner user ID, creation date, last activity date. All this stuff is in here. And we're using parameterized dynamic SQL here. We're using that because we do not want to lose our company data either by, giving up on performance and moving to Elasticsearch with no password, or by writing the unsaved kind of dynamic SQL where you might do something like, end a string there and then put owner user ID in there, because that's bad news. That's how people lose jobs and data and livelihoods and, careers and all that stuff. But what we'll do is that we'll give one more check, and we'll say if that filter string is not null, if we built everything up in here, then we'll set the SQL string. We'll set the full SQL string that we're going to execute. We're going to tack the filter onto that. So that filter is going to get tacked on right at the end of this. Right? It's going to get tacked on right after this, where 1 equals 1. Then we're going to finish off that SQL string by closing out the common table expression, selecting everything from the post table, joining that to the common table expression that's going to do our filtering and our ordering up here, right? And then we're going to filter out the page number stuff, and we're going to order by whatever our row numbering is, right? So we're going to order by the row number because I don't want to have to figure out if I need to order by 17 different columns down here. I would much rather figure that out way up here. Now, sometimes people may want to order by multiple columns. That's tough because then you have to accept a comma separated list, split it out, do all sorts of weird stuff with it. At some point, users are wrong. That's all there is to it. And then what we're going to do is, just because I want to show this every single time, I'm going to print every iteration of this. In real life, I would probably implement some sort of debug parameter where I say if debug equals 1, then we'll print. If not, screw it. And then we're going to use our good friend SP-execute-SQL. And we're going to use SP-execute-SQL to run the safe kind of dynamic SQL that hopefully keeps our jobs, hopefully keeps us from getting hacked and losing data and all that other bad stuff. And then that will be the end of the store procedure. Now, that is fairly professional dynamic SQL. There are more tricks and other things you could do with it, but you know, for getting across the point of how to get paging queries to perform well, you don't really need all the bells and whistles for that. We really just need to have things. We really want to start with like the end result for the dynamic SQL and move on to the perf. Like, we've got this figured out. So what I'm going to do is I'm going to run our awesome paging procedure in a whole bunch of different ways. All right, I've got 4 or 5 executions of it. We've got query plans turned on, and I'm going to let this run. And this is going to, I mean, this is not going to be fast. So, well, these things run, and we start thinking about how we might want to accommodate users who need to search for things. And I think I hit the scroll bar and we went over too far there. In this one, owner user ID is null, creation date is not null, whole bunch of nulls, but we're looking for page number 1 with a page size of 1,000. We're ordering by last activity date ascending. This one, we have last activity date rather than creation date. We're ordering by creation date. This one here has owner user ID and post type ID. This one is going to order by score. This one here has creation date and last activity date and post type ID and score. There's like all different variations. The more columns you add in, the more columns you let people search on, order on, just the more crazy variations of stuff you can expect these queries to come in and want to find. Now, if we go look at the execution plans for these, they're going to vary in speed a little bit. None of these perform terribly bad. None of them perform terribly bad. They just don't. Right? This one, and they don't because I wrote them that way. Because I don't want to sit here and wait for a minute for five queries to execute them. I just want to get the point across pretty quickly. So this one here finishes in about 3 seconds, right? And we have a missing index request on creation date, include last activity date. And we pop down to this next query, and this one takes about 2 seconds, and we have a totally different missing index request. This one here is on last activity date score, include creation date. And if we scroll down a little bit further, we're going to have this one here. This one finishes in about 1.8 seconds, but this one has, again, a totally different, like, ideal index for it. Owner user ID, post type ID, score. And if we go down, just kind of scroll along with it, all of these are going to have different missing index requests. They're all going to take around 2 to 3 seconds. But, you know, if we have to run these search queries a lot, if like the main thing that kind of drives our application is people being able to search for these things and then maybe do work off them, do like work off whatever the search results are, if they just figure out like, if these search queries are like, just what does the person have to do next? Like, what does my day look like? You know, like what do sales look like? If these kind of search things are what really drive our line of business app and we have people running them constantly, we're going to run into bigger trouble than this. The way I wrote these store procedures, even though we don't have any good indexes, they will filter things down to a pretty narrow result set pretty quickly. So we're going to avoid a lot of I don't understand why this query that needs to return 1,000,000 rows is slow, like gazing off into the distance stuff, because it's just not pretty. That is not the kind of like me talk pretty someday stuff that I think that a lot of end users is like, I don't know what I did wrong. It wasn't me. It wasn't me. It was a stupid query, stupid database. But when I look at this, I don't feel good about taking a busy OLTP table and trying to keep up with all of the different indexes that might come from people searching across all sorts of different things. I don't want to try to keep up with, users are searching for this hot thing this week. We have to index for this. Oh, that's so last week. We need to now index for this other thing this week. I don't want to have to try to keep up with that. What I want is I want an index, or I want indexes, or an index, or some sort of sane, rational thing that has queries A, performing well, and B, I don't have to think about if users are going to totally switch things up and flip things around from day to day, week to week. Maybe I have a multi-tenant database. Maybe I have, a whole bunch of different users in different databases. I don't want to have to index every single thing differently because users are like, well, we use the application this way. And I'm like, well, we use the application this way. People just get so carried away with it. It just becomes like impossible to have sort of like a single like set of indexes, without having a lot of schema drift from database to database, sometimes user to user. I've even seen crazy people who separate users out by schema. There's all sorts of different things there that can make life weird and hellish. So if we try to think about how to index for all of those, right? There are all sorts of things to consider when we want to index for things, right? We have equality columns, we have inequality columns, we have the sort order, we have all sorts of different things. And all of these queries will look like they are the most important query in the world to index for, and all of them are going to have missing indexes in them, right? SQL Server is going to be like, oh, I need a missing index on this, I need a missing index on that, I need a missing index on everything. Please just create all the indexes and you'll never have to worry about these queries being slow again. But that gets us into a different set of problems. Now, the thing about row store indexes. The thing about row store indexes is that when we create a row store index, let's look at any single one of these missing index requests, right? Let's look at any single one that SQL Server might want. When we create row store indexes, right? This one will be on last activity date and score. We introduce a column-to-column dependency. So this column is truly independent. This defines the initial sort order of all the other columns in the index. If there are any duplicates within last activity date, then score will be in order by that. We got a question over here. One common thing that many people overlook. What happens to the user on page 7? New gets added. That's a really tough one to keep up with if you do the paging with SQL Server. That is something that well, actually not very much easier for that. But yeah, that is something that people come up with. But Dave, the thing is, people have no lock hints everywhere, so they don't really care about that anyway, I've found. So, good luck. So we have that. And so with all of these missing indexes, SQL, we could go and add them, but we would introduce all these dependencies. And an index that is on post type ID, creation date, last activity date, this might not be ideal for something that's on creation date, last activity date. We have score over here. It's just, these column-to-column dependencies can be really tough with row store indexes. It can be really, really difficult to manage all of them, to figure out which ones are right, which ones we want to order by. And this is where, again, newer technology comes in. Now, SQL Server 2012 did introduce column store indexes, which a lot of people do associate with, data warehouses. But we also have these non-clustered column store indexes. And non-clustered column store indexes, starting with SQL Server 2014 when they became writable, can be very, very helpful for queries like this. Because column store indexes don't have the same kind of column-to-column dependency that row store indexes do. Column store indexes, everything is stored. Each column is stored kind of independently. It's compressed independently. And we don't have to let's say that we had a non-clustered column store index on what was that good index that I had over here with a bunch of columns in it. If we had an index on post type ID, creation date, last activity date, score, we don't have to search for post type ID in order to search creation date well. We don't have to search post type ID creation date to search last activity date well. We don't have to search post type ID creation date last activity date to search score well. We can just sort of say, hey, I need this column and this column and this column. Column store has a couple cool things in it. The one that I'm talking about that would apply here would be column elimination or segment elimination, meaning that we could just skip over certain things in the index if we weren't searching on them or selecting them. So with row store indexes, an index that starts with owner user ID would be great for queries that start searching on owner user ID. But if we wanted to really search for score, we would have to search for owner user ID and score. If someone leaves owner user ID null and we have to search for scores, we all of a sudden things get a little bit trickier. And that same thing will go on across the entire index. So what we might want to do, right? So let's create this index real quick because it is, as far as I know, it's pretty quick. Right? Dave says that's evil. Yes, I know, but it's not the people's fault that they have to put no lock hints everywhere. The reason people have to put no lock hints everywhere is because Microsoft screwed up. They made that garbage isolation level known as read committed the default in SQL Server, which is, they probably blame on Sybase actually. But they made that the default instead of using multi-version concurrency control like any other sane database would have. And people ran into absolutely pedestrian locking and blocking issues with read queries and write queries. And so we end up with that, with people putting no lock hints everywhere, because that no lock hint is a lot easier than having to figure out why things are locked, why things are blocked, and fixing it, which should be fixed by turning on RCSI or snapshot isolation, like recommitted snapshot isolation or snapshot isolation. But let's face it, that's even something that people get scared of because they're like, oh, about TempDB, I don't just know what it does, I don't understand it. So we have the garbage isolation level known as read committed, and we end up with no lock hints everywhere. So people aren't evil, no lock isn't evil, Microsoft is evil for not giving us an optimistic isolation level by default. And that's just a fact. That is a pure fact. So one thing they got right with Azure SQL DB is by default the isolation level is read committed snapshot isolation. So one thing where I'm like, if you're starting a new app, Azure SQL DB might not be a bad idea because you would get past that stupid reader on writer blocking that a lot of applications run into. So we've got this index on the post table now, and it is each one of these columns is codependent on the column before it in the index in order to dictate what we can search on, what we can order by, all that other stuff. So if we run queries against this index in different ways, all right, we can run that, turn query plans back on. All right, these all run pretty quick, but what we really want for this paging query, because this paging query isn't going, or rather that index right there isn't going to fully help all the queries that we want to run to page by. So what we're going to do is we're going to create a non-clustered column store index on the post table on all of our user searchable columns. So we're going to start with owner user ID score, creation date, last activity, post ID, and then we're even going to have title in there because we're ballers and we can do that. And also I just don't care. Gawabunga says, I think is that Shia Buff praying with his weird hair? I don't know. But yeah, it sucked. Why would Microsoft do that to people? It's like they want consultants to make money or something. Idiots. So let's clear out the proc cache. And remember, all of these queries were running in like 2 to 3 seconds before. We had different missing index requests for all of them, and we were unhappy with performance. So let's go and run all of those. I'm going to run the store procedure in the exact same way that we had it before, except now all of these queries are going to finish really, really quickly. And we're going to have something kind of different going on here. We're going to see that SQL Server has chosen to use our non-clustered column store index to fetch our data from. And it's not going to really matter at all what the predicates are. Yes, we are scanning the clustered column store index, but if you're seeking into a clustered column store index, you have used Photoshop on a query plan. Sorry. But yeah, so in this case, the clustered column store index solves a couple problems for us. One, it removes the column-to-column dependency that a row store index introduces, so we can search for any combination of columns that we want, and it doesn't really matter. accessing that column store index is very, very quick across every single execution. This one was 43 seconds. This is 43 milliseconds, 142 milliseconds, going down the list, 165. We will still get some dumb missing index requests. SQL Server's like, no, we could totally make this faster. Just get the row store thing in there. What SQL Server's missing index requests don't understand is batch mode. But by God, I wish they did. I wish they did. But we can see that like these queries all got a whole lot faster. Now, one thing that we'll find, especially with column store indexes, is that the batch mode sorting is okay here. Now, I'm going to go a little bit more in depth on column store than I normally would talking about it. But column store, when you sort data in batch mode, sort operators will be single threaded, right? All of the rows that you need to sort will end up on a single thread in batch mode queries. But not if they're a child operator of a window aggregate. If they're a child operator of a window aggregate, now all of these queries are single threaded anyway. They're all running at DOP1 because they're so quick and cheap and easy. SQL Server's like, we don't even need to go parallel here. But in a parallel query, all those rows would end up on a single thread unless the sort operator is a child of a window aggregate, in which case it can be fully parallelized. So he says, I know what I'm going to be testing first thing in the morning already. Could column store be the answer to my paging proc? I've had very, very good luck testing it. The one thing that I do have to caution you on is SQL Server version. So if you are on Standard Edition and you are not on 2016 SP1 or higher, you will not be able to create these column store indexes. If you are on 2016 SP1 or higher, you can create column store indexes in Standard Edition, but you are on Azure Managed Instances, you are all set then. But I'm just going to throw this out there for anyone else who might be watching. If you are on Standard Edition, all column store operations are limited to max.2. So that's creating column store indexes and running column store queries. No matter what you have server level, query level, database level, max.2 set to, they have a cap of max.2. So watch out there. So that sucks. But the column store index here has given us much improved performance. It doesn't really matter if what complicated predicates we pass in, whether it's just searching on a creation date, whether it's searching on last activity date and score, whether it's searching on all this other stuff. No matter what we do, all of these queries ended up being a lot faster. And this will even be true if we need to search some text filters. Now, one thing I didn't do in when I was executing the procedure before was search the body and title fields, because the body and columns. If Joe Selko or Aaron Bertrand are out there watching, I didn't mean to call them fields. I meant to call them columns. But I slipped up because I was thinking about feelings, and I was thinking about being outside because I haven't done that recently. Busy working on things for all you nice people. So what I'm going to do here is search on body and title, and we're going to see that this actually ends up being pretty quick too. All right, so this ends up, I mean, it's not quite as fast. We still have to do a little bit more work, but it still ends up being pretty quick, and I will take that over what we had before. Lee says, sorry, just need to clarify, is it the lack of column dependency or the batch mode that is helping us here? It is both. So it is the lack of column dependency within the column store index means that we are free to search and order by columns just about however we want. But batch mode itself is going to help us with the data reading. So if we go back and we run all of these, I'll show you what I mean. So when we read data from the column store index, this part does happen in batch mode. Right? If we look here, this is in batch mode. Good. This sort is also going to be in batch mode, which is okay for two reasons. One, this is a serial plan anyway, so it doesn't matter if it's single threaded or not. I mean, it might if you had to sort a lot of rows, but we don't. But also, it's the child of a window aggregate, and window aggregates are something that you only get with batch mode operations. So this whole part of the plan does end up being in batch mode. The top is row mode. The filter ends up being in batch mode as well. The nested loops join will never be in batch mode. Well, I won't say never, because it might get implemented someday, but right now we do not have batch mode nested loops. And this seek over here, because it's a row store table and we're on SQL Server 2017, the seek will also be in row mode, but in SQL Server 2019, we could see batch mode seeks, which is so cool and fun and exciting and sexy. So Lee, to answer your question, it is a little bit of both. So the column store index column independence or independency, whatever you want to call it, the column independence allows us to search through columns kind of however we want without needing to worry about which order the index key columns are in. And then batch mode very specifically gives us some heightened performance when we need to scan through data, because we will get rows coming out in batches rather than row at a time. We'll get all sorts of nice stuff in here. We'll get some actual number of rows and actual number of batches. So we had some nice spread over here. And so they work together. It's not just one or the other. It is both things at the same time. All right? Pretty cool stuff. So let's go and drop that. I need to always remember to drop that index from the post table, because if I don't, then I will go to write another demo later and it will fail spectacularly, because column store will kick in and make things different. Yay. Yay, 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 yay. So that is how that is my favorite way to start tuning paging queries, because paging queries can be notoriously difficult to tune. And that's the end of the demo. Now I'm going to put this up again, just in case anyone missed it before. If you join me, oops, I should probably stick the link in chat here. I should probably learn how to highlight things too. That's a good start, right? It'll be a good start to the day. So there is the link to the event I'm putting on. It's going to be this Friday, June 26th, starting at 10 a.m. Eastern, going until whenever you're done asking questions. There's a coupon code for people who attended the event. It is PagerDuty. It will get you $75 off the $200 cost. So it will bring it down to a pretty easy $125. That's pretty good, considering that along with being able to come along, learn from me for a day of SQL Server performance tuning, you also get access to all of the video training. Bradley says, if you already paid, is there a way to get the discount? No, sorry. I will find another way to make it up for you. Make it up to you. Just shoot me an email or something. I can't retroactively do it. I don't know. You could cancel and rebuy if you want, but I don't know. I might be able to give you something worth more than $75 if you don't do that. So who knows? So yeah, you get that discount code there. Let's see. G D'Onofrio says, would max stop limitation to 2 would be any useful if you have SQL Standard? So I have sort of mixed feelings on that. It can still be useful and helpful, but one thing that has bitten me a few times is if a lot of people are testing on Developer Edition. And when you test on Developer Edition with Column Store, you can end up with all the DOPs you want. You can end up with very good query performance. You can end up with just a lot of things that look a lot different than when you go and try to implement Column Store stuff on Standard Edition, because there's no way to tell Developer Edition to act like Standard Edition. I always test on prod. Yes, good job. That is the safest way to do things. SQL Dev DBA says, will Friday's session be available as on demand? So not Friday's session exactly, but I have recorded all of the material that will be in Friday's session, and that is up in the video training already. So if you need to review it, it'll be there. This is my first go around streaming for a full day, so I don't know if I want to record it just yet. I might just, I'm going to see how this one goes and see if there's anything I need to tweak or fix before I record it, just because I don't want the first thing to just be full of shame. Things have been going pretty well with these, so I'm not terribly concerned. I just want to make sure that I have everything really locked down before I put that out there. But I do have the pre-recorded stuff up on the site if you want to, if you need to revisit things from the Friday session. He says, thanks, I'm looking forward to testing out some scenarios tomorrow with our paging procs. Yes, let me know how that goes. I am always interested to hear how techniques that I've found while, working with people, consulting out in the wild, apply to all sorts of different scenarios. Maybe you'll find something weird or fun or different about it than I found, but, whatever. And so, I don't know, it's been like an hour, but if anyone has sort of random general SQL Server question, doesn't necessarily have to be about what we talked about today. I'll stick around for a couple more minutes to see if any questions come in. Otherwise, I'm going to get out of here and, I don't know, hydrate, look outside longfully, wistfully, as they say. Something like that. Wonderful stream as always. Thank you very much. I'm going to try to do one every day this week, leading up to the class. I'm going to I'll work through some of the material here and there. I mean, it's not going to be like the full day of material over the next few days, but I'll pick some stuff here and there, like a half hour, 45 minutes, maybe an hour worth, depending on how long I end up talking for. It's all up in the air. It's all crazy. All right, cool. So just some thanks coming in, not really any questions coming in. I will see everyone tomorrow, probably for a stream. I will try to get on a little bit earlier. Today I had some things to do, so that I couldn't get on quite as early as I wanted, but tomorrow I will be on a little bit earlier in the day for thanks. Yes, thank you. Started before 5 a.m. Well, technically half of them do. 50% of all SQL Server streamers start before 5 a.m. I am not that SQL Server streamer. I wish I had that brain. You're welcome, Mike Jim W. All right, I will catch everyone tomorrow I don't know what I'm going to do yet, but I will do it, and I will have fun, and I will make you have fun. And if you don't, you're dead to me. So, all right. Thanks for coming. I will see you all mañana-ish. This code is available. This code is available to people who come to the class, G D'Onofrio. Not available to people who just watched.